Okay, so what we want to do now is to learn how to measure the voltage drops in a series circuit. Always remember that the most important part of measuring voltage in a circuit is you're going across the load. In this circuit, our loads are resistors. So we're going to measure across the load. And in a series circuit, those individual voltage drops that we will measure should add up to be the voltage total. In this case, we're using 12 volts DC. So first step, I have to make sure I'm plugged in to the right ports on my meter. And I want to make sure that my function is set to volts DC. Next, I want to check my range, and I want to try to estimate where my range should be for getting the most accurate reading that I can. In this case, we're using 12 volts DC, so I have 200 millivolts, which is way too low. 2 volts is more than likely going to be too low. 20 volts, I will definitely fall within the range that I want to be able to measure. So, let's go ahead and measure the first one. Again, we're going to measure across the load. Now, my first resistor here, or my first load, is going to be measured at 5.54 volts. It's not millivolts, it's not kilovolts, because on my range setting, I'm on the volt scale. If I were down at my millivolt scale, then I would have to convert it to volts. Again, something that my students have a real hard time with is when you're measuring voltage, you're always going across what you want to measure. In this case here, we want to go across R1, because what we're attempting to do is measure how many electrons are on this side compared to how many electrons are on this side. We're attempting to measure how much voltage is being dropped across there. And remember, voltage is nothing more than potential, all right? And how many electrons are at one point compared to another. So in this case, there's no need to break the circuit, because you only break the circuit when you're measuring current. Now, we want to measure the next voltage drop. Always make sure you're grabbing the right leads, because we use similar leads for our power supplies and our meters. Always want to make sure you grab the right ones. A lot of times students will accidentally grab the power supply meter or meter lead and move it over, and then all of a sudden the measurements get really goofy. So I want to measure the voltage drop across my second resistor here and here. And I am at about 12.62 volts, which is fine. It's bouncing around a little bit. Again, some of these junctions are a little old. And I want to make sure that my red is closest to my red, my black is closest to my black. And I'm getting a real good reading here. And so my first one was about 5.55. This one's at about 2.62 volts DC. Next, I want to move my negative over here, and I want to go across my R3, and I'm reading 3.8 volts. This is how we measure voltage in a series circuit. Now, a lot of times what's going to happen is you're going to do the math ahead of time. You're going to sit down, you're going to calculate out what the voltage drop should be, and then you're going to compare them to your measurements, which is what should be done. And if you're off by a little bit, that's okay. But if I'm supposed to be reading 5 volts here and I'm reading 3.8, that's definitely not close enough. But let's say I calculated it out and my voltage drop is supposed to be 3.82. Well, 3.8 is completely fine. We're always going to lose a little bit through the junctions and through our wire. This is a very good measurement here. And this is how you measure voltage in a DC series circuit.